One of the things that's important is how to start up a heat exchanger, how to put it in service. So first of all, if you notice, I'm sitting here on section 2.2 startup, and I need to fill and vent the heat exchanger prior to placing it in operation. So when I go to do that, one of the things I want to do is I want to minimize thermal shock. Those are two things that are important. See this from right here, this knowledge requirement says, hey, what's the definition of thermal shock? And we need to prevent it. So what it is it's when we have a difference in temperature that can actually cause a sudden contraction or expansion of the heat exchanger, and very often you can damage it by cracking welds. So what we're going to do is we're going to fill and vent with the cool water first. So the cooler fluid that's going to a heat exchanger will always be introduced first, and we're going to want that cool water to be vented till I get a solid stream of water coming out. So all of the air is out of the heat exchangers. Then I want to gradually warm it up by introducing the hotter fluid. So it says the warming of a heat exchanger should be done gradually to prevent thermal shock. And it tells us what thermal shock is here. It occurs when the temperature of a fluid in a system suddenly changes, resulting in a differential expansion or contraction of the metal. And that can be damaging. So there's the definition of thermal shock, and we want to prevent it by gradually introducing the hotter fluid after we've filled and vented the cold side. And that says when a heat exchanger is full, I will see a solid stream of water being emitted from the vent valves. So that's cool. And another thing we have to worry about, if you're reading this, I have to worry about water hammer. Water hammer can occur, and the definition of water hammer is actually the conversion of a kinetic energy of our fluid to a pressure energy. Because once again, excuse me, you can't create or destroy energy. You can only alter it in form. And what's happening is kinetic energy of the fluid is being converted to a pressure energy. And this can cause a severe pressure spike. And it can happen, especially when you have compressible fluids like air inside the coolant. So water hammer occurs when the velocity of a fluid suddenly changes and it is converted to a pressure energy. And that can be very damaging to pipe hangers, as well as other components in the system. So we need to prevent water hammer by getting a good fill and vent and then moving components in the plant in a slow nature. So up here on the upper right, proper filling and venting of a heat exchanger, it gives us the sequence at which we will start up. And it says cold fluid is opened to the heat exchanger gradually and filled and vented, and then the hot fluid is introduced, and it's introduced gradually to prevent thermal shock till we get a steady stream of water, and then we'll close the valves. And many heat exchangers will have operational vents, but these would just be fill and vents for placing it in service prior to. And then shutting down is essentially the reverse order. What's key to note is the colder fluid is always the first introduced to the heat exchanger and the last one removed from service. All right?